My name's Rajiv Nagar. I work in Microsoft. I help lead a data center networking team within Microsoft. You're here for the platform vision and strategy talk, the third in a series of 7 focused on networking. This talk is going to be all up networking coming to you from Microsoft. So we talk about Azure networking, and then we segue into the networking technologies that are delivered, that are commercialized, brought to you on premise. I'm joined here by my colleagues. Yusuf Khalidi is a distinguished engineer leading all of Azure networking, and Bala Rajagopalan is my colleague who leads another networking infrastructure team within Microsoft. So I'm going to, without much, the content of this talk is pretty simple. We're going to start off, Yusuf's going to start off by talking about Azure networking, and then the remainder of the talk, we're going to talk about what you can do with these technologies that have been derived from Azure, that have been commercialized and brought to you on premise, what you can do with them today, and what you can look forward to them going for in the near future. Just to warn all of you, this talk has been billed as a level 200 talk. We are going to certainly talk about concepts and an overview, but this is going to be demo heavy. So we are going to show you a lot of things that you can do today, and hopefully there'll be stuff that's tangible that you can take away with you. So glad that you're here. Thank you for making the time. Yusuf, it's up to you.
Thanks, Rajiv. Good morning. I'm Yusuf Khalidi, as Rajiv mentioned. I'm responsible for Azure networking. So I'm going to give you a quick overview of Microsoft networking stack all up as far as the cloud is concerned, talking about the backbone and all the software stack that we built to manage the network, be it the wide area network or the data center network. Then Rajiv will take over, and you'll see the same technologies that we have built for the large scale of the cloud becoming available for you on premises as well. That's the whole idea, guys. So Azure networking, one sole marketing slide. I will not spend much time on it. The point here is this. We are truly informed by these 3 pillars, if you will, for us. Hyperscale, which I hope to impress you in a second, how high scale of a system we have built. The enterprise grade and the high-end features that many of you have been asking us for. And the hybrid. Hybrid is the focusing function, if you will, we use. Linking what we have on premises, what you have been building and using all these years, with the cloud. And it's not either or, it's a connection between the two. It's as simple as that, guys. Big scale, enterprise focus, and keeping what we have on premises while expanding to the cloud. A bit about our scale, and this may actually surprise some of you how big we are, really. We have a global footprint, as some of you may know. These are Azure regions. Think of them as data centers, even though, frankly, there are regions. Each region is a bunch of data centers. We are in 19 compute regions globally. These are open today. We are actually more than AWS and Google Cloud combined, available to you today in this room. This has been a multi-year journey for the regions and for the network that connects them, which I want to tell you more about it now. In the cloud, we have been experiencing hypergrowth. Some numbers behind me, we publish many of these numbers. I don't expect you to remember them, and actually myself, whenever I see these slides, they're usually already out of date. The point is, we have a lot of growth here. We're talking terabytes of storage and transactions. We're talking big numbers here of directory lookups, big investments, and so forth. Now, this hypergrowth is basically leading us to have hyperscale. And this is a network-centric slide. We have hyperscale in the network, guys. I mean, we today have 85-plus exchange points for ISP peering on the internet. What this means, in a simple term, when you connect to the cloud, be it from your phone in this room, be it from the road, whatever the case may be, you are going over the internet through some ISP, and you're hitting our backbone very quickly. These are 85 exchange points, more than 4,400 connections, and more than 1,600 networks. Just think about ISPs, if you will. And this is important, because we can build all we want to on-prem, we can build all you want to in the cloud, but if you cannot connect to it, it's a problem, of course. And you look at the numbers, of course. We have so much fiber, it's amazing. For example, in the US, I mean, you can wrap around the earth 4 times with the fiber we have in the US only. This fiber, by the way, we have our own optical fiber transit network in the US with a lot of fiber traffic, if you will, all over the globe. This is what enables the cloud to be what it is, in terms of scale and the like. And by the way, it's all configured and managed through software, which is the core point of this presentation. Big investment. Now, the way we built this wide area network, the way we peer and we decide on peering with ISPs is a function where the internet users are. And this is basically how, if you look at the density of these colors in the countries, we know who uses the cloud. We know where our customers or your customers are. And we make sure we are highly connected with multiple ISPs in all these regions. And again, it's been a long journey. Remember Hotmail days, MSN Search, Passport, and so forth? The journey started way, way back then. We only accelerated with the public cloud. And for those of you not familiar with Azure, the way it works is you decide where to store your data. You decide where to run your applications in one or more of the regions behind me on the slide. It's purely your policy. In some cases, you want to be in a given region because it's closest to your customers, or because geopolitical boundary considerations, or you're going to be in multiple of them for high availability, global presence, and so forth. The decision is yours. Key for this talk, though, is that the network that connects them, the wide area network, has all the properties I described earlier, and it's available to you. And I'll give you ideas how we can use it as well. If you double-click in any given data center of Azure, you see a transformation of the network from a classical north-south tree layer 2 network to a mesh layer 3 high bandwidth east-west optimized network. I am pretty sure you have some spectrum on your on-premises, probably closer to the classical one. What you will see from what I'm discussing here, the same bits, the same software SDN stack we have implemented to manage this high mesh network, high performance network will be available to you as well on premises. This innovation was needed, by the way, because the computational models are changing. In the old days, it used to be a simple website hosting. Request comes in, you come in through a front end, maybe you go to a backend SQL database, and some HTML page eventually comes back to the user. That pattern is still there, but now we do a lot of things within the network. We do replication, east-west traffic, we do computation, we do MapReduce, and so forth. SQL Always On, for example, uses the network between these nodes and so forth. So you want that east-west traffic, hence the newer mesh-like networks. And if anybody wants to know more details of this technology, we have a lot of published information about it as well. Key, this whole talk, and everything you'll see, all the demos and the like, is that we are shifting how these networks are built from proprietary custom hardware to an SDN stack. Don't get me wrong, we still have switches. You have to move the bits around. But the intelligence is moving from locked-in switch router vendor-specific APIs to an SDN stack. We're shifting load balancing, for example, from hardware load balancers to software load balancers. In Azure, all traffic goes through software load balancers running on VMs. And you can see it's a technology coming to you on premises as well. Similarly for the control plane, the APIs, the way you configure the templates for the network, all these things are done through software in Azure, and they will be showing up on premises and with the server as well. This is not something we invented yesterday. I started on Azure when we started the whole thing in 2006. It's been, what now, 9-year journey. So we have a lot of software that it took us a number of years to get right, and now will be available to you as well. Big picture, in Azure, you define your virtual networks. It's a boundary in which you can have your own subnets. You can bring your IP addresses. You can segment them. You can put ACLs. You can put security groups on them. You basically can define how the traffic is routed within your virtual networks. These virtual networks, by the way, reside in one of those regions I mentioned earlier. You can have as many as you want to. The scale is nearly infinite, but don't take me literally, of course. You can have as many as you want to. And you can segment them like you see fit. You can access them through the internet. All the exchange points I mentioned earlier are crucial to get you there quickly. And you can have backend connectivity back to on-premises, to the stuff you already have today. And some of the demos you'll see will illustrate how the hybrid solution works here. You can connect back on-premises through private connectivity or over the internet as well. Security is a big deal. It's a multi-layered approach. We have infrastructure support in Azure, for example, a highly scalable global DDoS prevention system, all the way to features. These concentric circles or ovals or ellipses you see in there are features available to you to configure your virtual network ACLs, security groups, and so forth, down to what you want to put in your VMs. You can always put a firewall there, and you should. You can combine them and mix and match as well. One feature which is very interesting, to be honest, and very important is network security groups. So within a virtual network, you can have multiple subnets. Each subnet, you can define on it network ACLs. And you can define the ACLs on the whole subnet or any given VM in a subnet. And you can define the whole subnet in such a way that when VMs scale up, scale down, you add more to the subnet, the ACLs are automatically applied to the whole subnet. Remember, it's all through software, guys. This whole SDN magic, what makes this thing happen. For those of you who have on-premises classical networks, you know what I'm talking about here. To do this thing in today's networks, you have to go log on to your favorite box, issue the commands, make sure they're consistent, and if somebody changed the application on you, you have to worry about what happened. And this system is all through simple templates and APIs. And when apps start or stop in a given subnet, the ACLs are applied to them as well. And this is a key feature, for example, to enable you to build DMZs in software. You can have multi-tier application services in software. No physical anything, it's all virtual. Another key thing you need to have are, of course, network virtual appliances. On premises, classically, we all used to buy the physical firewall, the physical WAN atomizer, the physical layer 7 load balance, whatever the case may be. Increasingly, we have them now available as virtual machines, right? The same applies in Azure. So the same expertise you may have today in a given brand, and I'll show you a bunch of vendors in a second, can be applied as is to the cloud now. So you can combine what you may have on premises, what your corporate policy dictates, what vendors you're most comfortable with, and have the same experience in the cloud. Build a virtual network, put your virtual appliances there, and you go. So just a few examples, and all these brand names are available in Azure today. And by the way, in Azure, you typically go to the marketplace, get the VM already configured for Azure, and you go from there. You can build, for example, a DMZ. You can put in there firewall. You can put routers in there. You can put IDS, IPS as virtual appliances, brand name virtual appliances. So if you're used to a given Fortinet or a Checkpoint or a Cisco methodology, box, command set, same applies to the cloud. So you can build a DMZ this way. This is basically an example. This is our current network virtual appliance ecosystem. And you can use them to build the DMZ I mentioned earlier. You can use it to do WAN automation. You can use it to do things like layer 7 load balancing and so forth. Okay? And we work with all these people. And if you have any vendor in there or a partner who's not listed, please tell us. In addition to defining your virtual networks in the cloud and doing all the stuff I told you about, you have multiple options how you can reach your VMs, your networks in the cloud. You can go through the internet connectivity, the first row in this figure, and hence all the ISP connectivity is key. You can decide to build VPNs. Now we have multiple flavors of these as a service. So you can do a point-to-site VPN from your laptop right now, connect to a virtual network in the cloud securely, or you can connect your on-premises VPN device to your virtual networks in Azure. The first three top scenarios go over the internet through the peering network. You also have an option to do private connectivity to Azure, where you bypass the internet completely. You are no longer beholden to the internet issues with packet loss and security considerations and, frankly, finger pointing. Why is my connection slow this morning? You can have a private connectivity through something called ExpressRoute. So for the VPN ecosystem, again, we partner with the leading VPN providers out there. These are the devices, be they hardware or software, that you put on premises in your VPN to connect to the cloud. And I'm pretty sure you see one or more devices you're already using here. For connecting privately, you can, as I mentioned, bypass the internet. Classically, you have a picture like this, where you may have your branch offices, on-premises data centers, whatever the case may be, and you connect effectively. You may have your own wide area network in the company, but you connect to the cloud that way, through basically the internet. Instead, what you could do is use ExpressRoute and bypass the internet and make the cloud part of your WAN. So in this picture, you have all the entities you may be managing today on premises, which we assume we're going to keep and expand. But you're going to augment them in a hybrid fashion with the cloud. So you can have Azure on your WAN on your terms, bypassing the internet. So with ExpressRoute, you have predictable performance because you are not using the internet. Your packets leave your network, go through one telco or exchange provider that you and I agree to, and hits our wide area network. That's it. No ISPs in the middle, no packets going who knows where. You have performance, you have security, you know how things are. You can build a DMZ on-prem, you can put a DMZ in the cloud, everything in between is basically running on the private network. You can get a lot of throughput of this thing. An ExpressRoute circuit, which is highly available, can be up to 10 gig, and you can have multiple of them, of course. And frankly, each circuit is actually 2 because it's highly available. You can burst up to 20 gig. You can start with megabytes, bits per second, go to 10 gig and more by having multiple of them. And it's actually cheaper if you're pumping a lot of data for some scenarios to go through ExpressRoute than your typical internet costs as well. And we have cost calculators or what have you to show you where the cutoff points and so forth. We're excited about now expanding ExpressRoute to connect not just to Azure, but to all Microsoft services. And chief among them, Office 365 and Skype for Business. So the same circuit you buy to connect your network to us can be used to go to Azure, Azure services, Azure VMs, VNets, and to Office, and for Skype for Business as well. Same models, same administrative models, everything else. It's actually very nicely done. Quickly, we have a large set of partners here as well. Remember, guys, we're very partner-focused. The list at the bottom here are the list of current ExpressRoute partners. They are among the biggest telcos on the globe, plus the biggest exchange providers and hosters in the globe as well. You can decide to, for example, co-locate in a hoster, an exchange provider, and connect to us through an Ethernet connection. Or you can take your corporate MPLS wide area network and connect to us through one of the high-end telcos out there. And I'm not sure where you are come from around the globe, but we probably have one of your more providers already on our system. It's all up and running, guys, here. There's no future stuff here. And this is our current entry points on our wide area network. So in addition to choosing where your data resides, in addition to choosing where your computation resides, you can also choose how to enter the wide area network through one or more meet-me points. And these are the cities available today. And you would choose an entry point, by the way, for latency. You choose a couple of them or more of them for availability and so forth. So for example, you may decide to connect your WAN to US West and US East, or US West and Singapore. Okay? And you can fail over between them and so forth. This week, we're also announcing an add-on feature to ExpressRoute. Remember those circuits, the marketing slide I showed you with the enterprise stuff? This is a proof point. ExpressNow now can give you global connectivity. So if you connect to us, an example between US West, and you want to get to your data in Singapore, you can do so now, bypassing the internet. We will transit the traffic for you over our own wide area network as well. So you have global connectivity now with the premium add-on. In addition, we now have even more routes available to you to advertise into your ExpressRoute network. Today, actually, we go up to 4,000 routes, which is quite a lot. We now have support up to 10,000 routes. I know most of you will not need 10,000 routes, but a few of you will need this one. And I don't know anybody else who can give you this, by the way, from the cloud providers out there. Lastly, you can even have more virtual networks connected to your ExpressRoute. So we're up from 100 to 10. Why am I showing this slide? Again, we have entry points for you to the cloud, very simple stuff, internet connectivity, some VPN, all the way to very high-end private connectivity to the cloud. You choose, depending where you are in your journey. Finally, and I'm going to hand the microphone in a second, you can put the whole thing together in multiple scenarios. We've also announced now the ability to describe all these things through templates, through a resource management infrastructure that's actually applicable both to on-premises and the cloud. So I know I gave you a quick bunch of plumbing and features and the like, but we are publishing templates of how this network can be configured. And the templates are executable templates. You click on them and instantiate the network for you virtually in the cloud in a matter of minutes. So not only do we start up the VMs for you, but we configure the network for you, configure the subnets for you, the IP and the connectivity and so forth. And we have multiple talks, by the way, during these events that discusses every major point I discussed as well. So before I hand the microphone, the journey has been a multi-year journey, 2006 to today. And everything I told you about is up and running in the cloud today, no future stuff. Now, the future stuff is the very near future is that the same software technology, same APIs and templates will be available to you on premises as well. And you can decide how to apply them, either for your networks on premises, use them in the cloud, or most likely in a hybrid fashion between the two. Thank you. Rajiv?
Thank you, Yusuf. So hopefully you got a sense of Azure and the technologies that we have implemented in Azure that deliver all of that functionality to you. I think Yusuf has reiterated this a few times, but Azure has gargantuan scale. And in order to deliver on that very large scale, there were a slew of technologies built, innovated upon in Azure. And our whole development cycle is pretty simple. We implement these technologies, we prove them at scale, we commercialize them, we bring them to you so you can deploy them. And that's what the rest of the talk is going to be. So you're going to see a few demos now, and I'm going to walk you through what you can do today. And that's the key point, which is cloud-inspired infrastructure. You've heard about this recurring theme throughout this conference to date. Let's talk a little bit about why you would care. Why does it matter for you if you want to deploy these technologies on-premise? And let's take the dimensions that are listed over here. Productivity. Today, if you want to onboard an application within your own data center, it takes time. You have processes in place, and those processes are inherently, they're designed in order to, out of an abundance of caution. You basically want to ensure that you do not introduce any additional faults in your already overly complicated network. So onboarding an application or changing policies that are associated with that application takes a bunch of time. And that is what changes as you embrace the software-defined paradigm. You can literally provision virtualized networks in a matter of minutes. So that directly translates into business agility and unparalleled productivity. Let's talk about flexibility. Today, within your data center, depending on how your data center is configured, you have very fixed topologies that determine the placement of each tier of your application. In some sense, it's the tail wagging the dog. But that changes. That changes as you embrace this paradigm, this way of deployment, as you have a modernized data center akin to the one that Yusuf alluded to. You can determine application placement based upon your business needs, and they are not limited to an intra-data center deployment. In reality, you can actually have tiers of application span multiple data centers and span the Azure public cloud, all the way from the Azure public cloud all the way to your deployment. Efficiency. Your ability to optimize your capital expenditure, your operational expenditure based on your business needs. Not talk, something you can put into action today. There's a sea change going on, an innovation going on in terms of the capabilities of merchant silicon. Before, networking vendors had to build proprietary ASICs in order to bring to you the desired throughput, the desired latency required for your business needs. Well, now merchant silicon combined with the right software stack can bring those benefits to you today. We are going to illustrate that for you very tangibly today. And a truly converged fabric. So you can have disaggregated deployments with virtualized networking, with disaggregated storage, all in a converged manner using very cutting-edge technologies like RDMA. We will illustrate that for you today. Reliability. Inherently designed, you can now leverage software infrastructural components inherently that were designed for maximum resiliency. A key mantra within the cloud that Yusuf would tell all of us is, stuff happens, things fail. And the software stack was designed to account for such failures and to ensure service uptime, which is resiliency in the presence of those failures. And then protection, which is your ability to ensure that your assets, your business assets, indeed are secure. So I won't use fluffy marketing monikers like microsegmentation. What I will tell you is you can now implement very granular security policies at every tier in your application that determines exactly what traffic flows between what layers of the application, between what virtual machines or containers within. A key thing that I want you to take away from this is we all look at Azure and we look at that scale and we say, well, maybe, just maybe, all of this only applies to very large-scale deployments like Azure. I have 4 words for you. Size does not matter. You can take this set of technologies and you can deploy them on 3 machines as a proof of concept. And then you can start scaling. You might have about 15 or 20 physical hosts, or you might have 100 hosts, or 300, or 3,000. Or you can just take these units of scale and replicate them and perhaps scale to 1 million odd machines like Azure does. But your ability to leverage these technologies to get these benefits is independent of the level of scale. The benefits that you get accrue are even larger as you go to higher amounts of scale. So let's talk about this a little bit more in detail. What I want to reiterate is this set of technologies that were born in Azure are available to you today. I'm not talking about the future. I'm talking about what you can deploy in your data center in production right now. Your typical data center, a bunch of racks, a bunch of nodes, your routers, your dedicated fixed function physical appliances, and then your edge routers. This conceptual figure should be familiar to all of you as you deploy networking within your data centers. This is akin to what we deploy. We do not mandate that you do a forklift upgrade of all of the investments you've made in physical hardware within your data center. But what we do is we take all of this deployment and that becomes the plumbing. So that's your physical infrastructure. Note that today you are constrained by where you can put your applications within this physical infrastructure because of the way you've deployed your hardware infrastructure, your networking. Well, no longer the case. So you take all of this physical infrastructure, and then we layer a whole bunch of software on that. So let's see what comprises this abundance of software that utilizes the plumbing you already have in place. This is where the intelligence comes in. This is what Yusuf just spoke about. This is how Azure deploys. So we start with the fundamentals. Now, switching, routing, and core isolation capabilities are delivered to you as part of that software stack, in conjunction with fundamental network services like naming and numbering, DNS, DHCP, and a comprehensive suite of IP address management capabilities that span physical and virtual deployments. So a distributed switch, intelligent distributed routing, these are core networking components now delivered through software, leveraging your physical hardware, plumbing, or the pipes you already have in place. You can see where the intelligence has moved to. On top of this, we layer a bunch of additional services. Which allow you to take your now intelligent deployment and connect it to the rest of the world. So for example, within your data center, we don't expect you to virtualize everything all at once. So you will virtualize components of your data center, and you might still have physical deployments in place. Well, our forwarding gateways allow you to do exactly that. We have network address translation, NAT capabilities, which is delivered to you as a NAT gateway. In addition to this, we have a set of capabilities that allow you to connect to Azure, as Yusuf said. So site-to-site services, site-to-site services that allow you to go across data centers, your own, to connect your data center and your intelligent virtualized deployment to other third-party cloud service providers, or go from your data center all the way to Azure. And then you can do that in a low latency manner using ExpressRoute. All of this is married today, available to you, with a set of capabilities that allow you to provision, orchestrate, manage, control through the Azure Pack and through System Center. So what does this mean for you? What that means is you can take your traditional 3-tier application, which is now running virtualized. So you have a bunch of VMs, Windows VMs, Linux VMs running your workload. This is a very typical 3-tier deployment. And you connect these different tiers through these software-provided switching and routing capabilities, exactly as illustrated over here. Still using the physical pipes, your plumbing, but those components are now in software. The policies are now instantiated in software. And then you take this deployment, this entirely virtualized deployment, which has a virtualized network, which has these virtualized workload tiers, and then you can connect it through these edge services to the rest of the world. And this is your package, your line of business application that you then take, and then you simply deploy it within that intelligent, modern data center that you would have constructed. But of course, all of this resides on a layer of foundational technologies that I will talk to you more about as I talk about upcoming set of enhancements very shortly. This is not all. You can now take this line of business application along with its virtualized network connectivity, and you can have instances running cross data center, whether yours or in Azure, all connected through the services that we deliver to you through software or with ExpressRoute. And now you have your own cloud, which is truly a hybrid cloud that you can deploy today that spans these multiple data centers and extends all the way to Azure. So you can take a tier of your application and move the entire tier to Azure or sub-tiers contained therein. So hopefully this gives you a sense of what you can do with technologies available to you today. Let's see all of that in action, and I'm going to invite Greg to the podium, and he's going to walk you through that.
All right, thanks, Rajiv. So let me get switched over real quick. Just a second. All right, so what I'm going to show you is I'm going to show you the life cycle of an application that I'm going to deploy. It's going to be an application similar to the one that Rajiv just described. It's a blog that's a two-tier application. I've already got the VMs deployed, but I'm going to show you this deployment from the perspective of the network and what we do to actually create these software-defined networks behind the scenes. You can see I have a backend that's running SQL Server, a couple front-end VMs that are running IIS, and I've also deployed a Linux VM. It's not used by my application, the Linux VM, but I know it's important to a lot of you, so I want to show it as a first-class citizen where we can do a lot of the same policies and set the same port settings that we can do for the rest of the Windows VMs. Now, everything I'm going to do today is going to be done through this one PowerShell script here. I've got a number of utility functions. I've got some System Center calls in here to create a new virtual network, create a new subnet, and create an IP pool. I'm not showing you this to give you a tutorial on PowerShell. I'm doing it to show you that I'm not actually touching my physical network. My physical network is designed to be very reliable. It's designed to be very high performance, but also be very static. I don't want to touch it every time I do a deployment. So everything in here is created by just talking to System Center and Hyper-V to get the job done. So let's actually kick it off. So here we go. This is the script I just showed you. And so the first thing we're going to do, before we do that, here's one of the VMs that I've got running. This is just a script that's running in a loop that's showing you the current IP address, and pings are failing because the NIC is not connected yet. So let's create a virtual network and then connect the network adapter. So I've talked to System Center VMM. I've created the virtual network. If I go down here, you can see it's actually already created. And now it's also going and connecting these VMs to this network. You can see it's already got the network coming up. It's already got an IP address assigned that VMM has injected into the VM. And in a few seconds, as the other machines come up, you'll see the pings will start working. So you can see all through that script, I've now gone and created a virtual network and attached a number of machines to it. So if we actually look at the diagram, these machines are on a single network. They can all talk to each other. Now, that's great, but at some point, you want them to be able to talk to the rest of the world. So that's as simple as adding one of these core services that Rajiv talked about, which is actually the edge services, a NAT gateway. So in this case, I'm now giving this network the ability to talk to the internet using network address translation. So if I go to my Linux VM real quick, I can see that it got an IP address. And now that the gateway has been added, I can now ping the outside world. I'll ping Bing. And you can see we added the DNS servers, and it's able to ping to the outside world. So the Linux VM works just as well as the Windows one. So now that we have access to the internet, now we have to really start thinking about security. I mean, it's better late than never. I probably should have thought about it earlier. One of the best ways to actually provide security to these applications is to separate the different tiers into different subnets. So I'm going to do that in my network by adding in one of the core services. I've added NAT. I'm going to add in one of the core services, which is this distributed virtual router that runs in Hyper-V. This will create a new subnet for my backend, and then I can create some access control lists, some firewall rules that will say who can talk to who on the front end. So I'm going to add that new subnet now. And you'll notice over here my backend IP address will change to that new subnet in a few seconds. The ping will fail for a little while as it gets reconnected. And there it goes. It's already come back. It's now on the new network. And it's up and running. So it's on the 146 now. These are small subnets /28, so that's why the 134 didn't change. So now I can actually open up my application. Let me go to my front-end tier. Wait for my remote connection to respond. Whoop. The joys of connecting back to Redmond for a demo, as you can all see. Looks like my VPN connection got disconnected. Bring up my VPN settings. No, it says I'm connected. That's interesting. All right, I'm going to have to switch over to the video at this point to finish this. I do have a backup video. So unfortunately, the VPN did not cooperate at the moment. So let's skip ahead in here to get up to the point where we were at. Can you bring up the backup RDP file on there? See if yours works. OK, we'll skip up ahead. OK, so here I've added the second subnet. Oh, we've already got past that part. And I'm showing you that the application now works. I can connect to my blog that I've deployed, and it'll come up. I can actually connect to both front ends at the same time from this single front-end machine. It'll take a few seconds for it to load the first time. Here's my networking blog. It's going to come up and run. I'm going to log in and do a post real quick. But while this is running, go back to my diagram, show you where we are. So we're going to add the firewall next to show you that now we can actually block the traffic between the two front ends. Because if one of them gets compromised, you want to make sure that it can't attack the other VMs along the way. So this is going to go and do a post real quick to show you that it is live. And so now I have a post in, and that went into the SQL backend of that VM. So now we're going to apply the ACLs. This is a simple rule that basically says anything that's coming in and out of these VMs that's on the same subnet, we want to block that. So this is just showing you the rule. It's saying deny inbound and outbound on the same subnet that the machine is currently on. So this is going to get applied to both of the front-end VMs that are in my environment. Okay, and so now you can see that I'm going to query my local IP address, and I can still get to that and also show me, and I'm going to edit the post, that I can actually talk to the SQL database on the back end in the other subnet. But if I connect to the other front end from this machine, it's just going to sit there and spin. It's not going to actually connect. It'll just think about it for a little while. Eventually, it'll time out. All right, now that my application is deployed, it's working, I have it secure, I can actually extend the reach of it now to some additional users. I'm going to do this by establishing a site-to-site tunnel to one of my remote sites. So this is going to use, again, another one of the edge services that Rajiv talked about. It's created the configuration already, but since this is an on-demand tunnel, it starts off disconnected. When I go and refresh the blog, it goes and switches to connected mode. So you can see, and it'll be the same post that I did before and the edit that I made along the way. All right, so I'm going to pause it here for a second, because now the next thing I want to do is I actually want to scale this application up. I want it to go big, and I don't have the capacity for that myself. So I'm going to ask Yushin here to actually help me out and tell me how I can use Azure to extend this.
Sure. My name is Yushen Wen. I'm program manager in Azure Networking. And for this demo, consider me as the cloud architect. So my job here is to set up hybrid application that span both in Azure to on-premises. And Greg actually shows site-to-site VPN going through the internet. We're going to kick it up a notch, basically using ExpressRoute. So this is the dedicated private connectivity and high bandwidth between Azure and your on-premises data center. In the interest of time, Greg, can you switch over to?
Your section.
Oh, I'm sorry. OK, so what I have here, I'm going to show very briefly, is a hybrid SharePoint farm span across on-prem and Azure. So I have two hypervisors here. You can see that I have AD, I have App Server, front-end, and SQL Server here. And I have a big IP running on-premises. Actually, we also have a Riverbed physical appliances running on-premises as well to optimize the traffic between on-prem and Azure. So what I'm going to do is that I'm going to show very quickly the other half of, of my setup. So this is the setup in Azure for the SharePoint farm, right? So if I zoom in a little bit, you can see the SQL, you can see the F5 big IP running in Azure. I have the application server, number 3, number 4, and I have the front end in Azure as well, and I have a Steelhead running. So we actually are not going to demo F5 and Riverbed here. We have a session tomorrow. We're just going to invite the partner to actually do the demo themselves. So here what I'm going to do next is I'm going to help Greg to basically scale out his famous blog to cloud scale. So that's what I'm going to do. To do that, let me just, we created a couple of virtual machines here. Oh, let me just remove this. So we create a couple of web servers here, and we connect to the same ExpressRoute circuit, right? So in order to make this work, in order for me to make this scale, what we also did is that you can see the Web 1, Web 2, Web 3 here. We are actually using the Azure load balancer actually in front of these 3 web services. So that's what I'm going to show here very quickly. Let me just zoom in a little bit. I think I click on one already. Let me just make sure I click on one of this. And then you can see that the setting is getting loaded. If you see all the settings, you can see the load balance set, which is what I'm going to show next. And the load balancer, you can see there's an internal web load balancer. So now Greg from on-prem, all he has to do is just connect and direct his traffic to the ExpressRoute circuit, and then this will all be linked together. So I'm going to hand back to Greg.
All right, fortunately, in the meantime, my VPN came back, so that's good. You can actually see my demos caught up to where we were in the video. I did a new post to my blog telling everyone that my VPN is back, and I love doing live demos. So now I'm going to switch over to use that ExpressRoute circuit by simply changing it over to a forwarding gateway. So this is now going to turn that edge from a site-to-site and NAT gateway into just a pure router. It's going to route from the virtual network onto my corp network where ExpressRoute is configured to go across into Azure. And so this will take a few seconds to run as well. While that's happening, I'll bring up my browser on my laptop itself. And once this finishes, I should be able to then connect to that virtual IP that Yushin just talked about, and you'll see my blog post will come up using the front end that's in Azure. So there it is. This is the same post. You can see it's the same post. I connected to the IP that Yushin created. So now my application's done. Over time, I'm going to need to make revisions to this. And so one of the important things that software-defined networking gives you the ability to do is clone your network in addition to the VMs that you have as well. So I can actually just whimsically create 10 more of these networks that I just created. And go to VMM. You can see them in the background. I just created 10 of these. Now I can actually clone the network and the VMs that go with it and into the same address space and test them and test new versions and make sure they work the way I want to, and then roll out the next version when I'm ready. So all this available today. You can do it with 2012 R2. You can do this with the tech preview. And I'm going to hand it back to Rajiv to talk to you about what's coming in the future.
Thank you, Greg. Let's switch back. So that was pretty cool. I think the key takeaway, as you saw, and the reason Greg showed it to you using PowerShell, is the programmability that is now at your fingertips. In other words, you can essentially construct these virtualized networks that are secure, provision the right set of policies in order to secure them, still using the same physical underlying infrastructure, and do that at scale, as illustrated by Greg when he was showing you a dozen networks created, and you can scale that to hundreds or thousands of networks should you decide to do so. So let's talk a little bit about all of this was what you can do today. And going back to our initial theme, which was we take our technologies, we build them out for scale in Azure, and then we commercialize them and we bring them to market for you. Let's talk a little bit about what you can look forward to as part of the threshold wave of technologies. So until now, everything deployable. The rest of it is what's coming to you in the very near future. So again, we talk about your physical plumbing, a layer of software, and we still have the layer of software which provides the core set of services to you, the distributed switching, routing, and all of the other associated networking services. They're all over here illustrated. We have actually added or enhanced these services considerably. For example, our switching routing capabilities are now the same, exactly the same bits that are running in Azure today. But from your perspective, from a business perspective, they are the same set of capabilities, simply made better. Layered on this is a slew of additional network services. So as I mentioned earlier, you have a set of capabilities today in terms of your ability to take your virtualized deployment and connect it to a physical deployment intra-data center, or to use NAT services, or to be able to connect multiple sites together through site-to-site gateways that are multi-tenant, or be able to go to Azure using ExpressRoute. But we've gone ahead and we've enhanced these set of capabilities. Some notable enhancements over here are, for example, we now bring to you the same Layer 4 load balancing capabilities that are deployed in Azure today. So it's the same software load balancer that scales out to those gargantuan scales that Yusuf had mentioned that are now being commercialized and brought to you today. In addition to that, we are bringing to you distributed firewall capabilities that enable you, for example, to bring your own network-related policies that are in the physical world and apply them to your virtualized networking deployments, for example. So that distributed firewall service is also being commercialized and brought to you as part of these sets of enhancements available to you in the near future. We don't stop there, however. As Yusuf mentioned, there's a slew of third parties that we work with who deliver best-of-breed virtualized network service appliances, or network virtualized appliances, monikers for the same thing. And so what we are bringing to you is this capability to do service chaining. So you can compose your own service that is comprised of different virtualized appliances now on premises. So you can take these best-of-breed appliances, and then you can create your own service out of them. So service structure combined with third-party, the ability to interject these third-party virtualized appliances is also being delivered to you as part of our set of enhancements. I mentioned that all of this is built on a very robust foundation. So let's talk a little bit about some foundational investments that we've made. We have invested substantially in interoperability. And our interoperability starts with interoperability on the wire in terms of our tunneling protocols. So to date, in order for you to take these virtualized networks and deploy them on the same physical plumbing, we use an encapsulation mechanism called NVGRE. It's just a mechanism, and we've now enhanced that as part of our commitment towards enhanced interoperability, and we support VXLAN as well. So that's an illustration of our commitment to interoperability. This is on the wire. I will speak to this a little bit more as we talk about our control mechanisms and our ability to interop at the control layer. In addition to this, we are bringing to you, I spoke about convergence, a converged fabric that allows you to access disaggregated storage and also have virtualized networking tenant traffic flowing on it. That decreases your costs. We've taken this convergence a step further, and what we've done is we now allow you to use the same set of NICs that implement RDMA-based storage access, That's very low latency, very high throughput storage access, and use the same set of NICs running using merchant silicon for tenant traffic as well that are teamed. So you can have resiliency through teaming, and then you have a converged fabric for both storage and tenant access. In fact, not to steal Jose's thunder, but if you go to the next talk in this series, which is a talk showing you storage, or talking about storage, you will see the highest throughput connectivity that you can get in the market today, and RDMA-based storage access running on it, 100 gigabits per second, and you will see what that means to your storage access for your applications if you use this set of technologies. That's a pretty impressive demo. In addition to this, when I talk about foundational technologies, when you have your infrastructure, physical infrastructure, the way you decrease your costs is by having maximum density in terms of your application deployments running on this physical infrastructure. You want to use the latest and greatest speeds and feeds. You want to go from 10 to 40 to 100 gigabit networking. Therefore, you need a very low latency network stack. We have invested in that very low latency network stack, and Greg is going to illustrate that for you. Today, for example, we already have an impressive set of capabilities that allow you to move a few 100,000 packets per second per core when we are doing network, when we are manipulating those packets, for example, as part of our multiplexing for the software load balancer. In terms of our ability to move raw packets per second, we have improved this to over 10 to 15 million packets per second raw per core, small packets per second, that we can do with this upcoming set of enhancements. And in terms of integrating this with our distributed virtual switch, Greg will illustrate this to you. We've doubled our performance in terms of our ability to manage packets per second or get high throughput packet per second processing. So building on this, in addition to our foundational services, core services, and enhanced network capabilities, we interoperate with you've seen the new Azure-based provisioning capabilities that were demoed to you yesterday in the first part of these series of talks. We are completely integrated with that. We also allow you to use SCVMM for fabric management. And then, as part of the Azure stack of capabilities, we now bring to you a control layer. The control layer that is deployed in Azure today in the form of a network controller role that allows you to do unified control and management for both your physical as well as your virtualized networking infrastructure, all using this one common control plane that you can program to using REST, or you can utilize your scripting capabilities and use PowerShell. And again, in terms of our ability to interoperate, for example, in addition to using OMI to be able to talk to the networking infrastructure, we now go ahead and use OVSDB as another protocol that we can use to communicate with physical and virtualized infrastructure. So this is a comprehensive suite of capabilities that enhances what's available to you in market today. Again, going back to our 3-tier application deployment, you can now see the administrator using the controller mechanism to have a richer 3-tier application deployment that incorporates the software load balancing capabilities coming to you from Azure, that incorporates the distributed firewall capabilities coming to you, and that allows you to do service composition using third-party appliances that are chained together, again, all going through the controller. And then what you can do is take this richer 3-tier application deployment. Your policies are enforced through the distributed switch. The load balancer is now a software load balancer. This is your enhanced package, your virtualized 3-tier application. Includes your network, and you take the same application, you again deploy it within this evolved set of networking infrastructure, which is available to you in the very near future. Of course, this too scales cross data center, so you can now have this across data centers exactly as before, using a multitude of mechanisms. You have your hybrid cloud available to you that you can now deploy. And the same set of migration capabilities allow you to place your application anywhere within your data center, inter-data center, spilling over into the Azure public cloud. So let's take a look at some of these capabilities live that are upcoming, and I'll invite Greg back to the stage, and he will walk you through some of them.
All right, I'm back. So this time, I'm going to show you the same application, but this time deployed. Not that one. Deployed using the network controller for the network configuration. This is the new network controller. This is the previous application here. In my new deployment, I'm going to be using the network controller and programming it through REST and passing in the JSON documents. So instead of doing a procedure-by-procedure call like you saw with PowerShell previously, I'm going to build this big JSON document, pass that in, and it's going to do all the work when it gets to the controller, and it'll distribute all the policy. We're also going to take advantage of the software load balancer along the way. So first thing I'm going to do is I'm going to query the host using the OVSDB client tool. This is the same tool that's available today that's used to query OVSDB-capable physical switches. We've ported it to run on Windows now, and we're querying the Windows Hyper-V host in order to query the tables to show you the virtualization policy. Here, the table's empty. And I'm going to go and I'm going to create the same virtual network, or a very similar virtual network to the one that I showed you in the earlier demo, but this time it's using the network controller, and it's passing it in through a JSON document. You can see some of the address spaces getting passed in, the subnets are getting created, the VMs, which I already have deployed, are already running, and they're going to get created as well. In this environment, I have a network controller deployed in a VM. So you saw it on the circle on my previous diagram. And then I have, for SLB, I have what's called the SLB MUX. This is the component that has the virtual IP sitting on the front of it that then sends the traffic then to all of the back-end VMs that make up the next tier that it's load balancing. So you can see that my virtual network creation completed. I'm going to go to one of my front-end VMs. It'll take a minute for it to refresh in, but it will start pinging. I'm pinging from my current IP to the back-end subnet. While that's going, we'll give it another minute for all the policy to get distributed. You can see if I just scroll back, just show you a little bit here of what's going on in here. Here's where I create the subnet, 192.168.0.0. There's a similar one for 192.168.1.0. Here's where I'm attaching the network interfaces to this virtual network, and this is all getting passed into the controller. Here's the other subnet right here. Let's query the OVSDB tables again on the host. And you can see that now we've pushed out all this policy that basically tells the host how to map the virtual network to the physical. Let's see if, there we go. Ping has started working now, so this virtual network is created. I can actually open up my application, and the same blog that I did before, we'll just connect to a few of each of the instances. And you can see this is now working. Sometimes it takes IIS a little while to refresh the cache to connect to the database, but we are connecting here. Connect to the third one. We'll see what happens. The fourth one. Yeah, this one hasn't refreshed yet. Whoops. All right. So let's move on. Now let's put the load balancer in front of this application. So we're now modifying that document that we did before for creating the virtual network, but now we're adding in the load balancer configuration as well. So this is basically allocating a virtual IP that we're going to put into that software load balancer MUX that sits in the network. And we're going to map that virtual IP to all of those VMs that make up my front end. This is the exact same software load balancing technology you saw in Azure in the earlier demo, but we've ported it then to run on Windows Server. So if I just scroll back a little bit here, if I can find it in here, you'll see the virtual IP. Right here is my private address that I've created on the 50.0.0.22, and I've connected these back-end machines. This makes up my front-end tier of my network. We look at the OVSDB tables one more time. You can see they're now configured to be load balanced on the front end. I can now go to my client, and assuming I don't hit the one that wasn't, yeah, I did hit the one that wasn't refreshing, but if I keep trying, you'll see that I'll hit different instances that do get the correct blog post up. So it is rotating through each of the back-end dips. One of them is not functioning correctly. If I had a health monitor on there, it would have detected that and it would have pulled it out of the pool. Last thing I'm going to do is I'm going to apply the same firewall rules that I did before in my previous network, but again, this time through the REST API of the controller, passing in the JSON document. And now, if I go back to my front-end VM, which was this one here, and refresh, these will now time out because they can't now talk to each other. I'll actually close them so we don't hit the IE cache. Let's reopen a few of these. And they'll just sit there and spin for a while. They're never going to connect because there's a firewall rule in place. All right, so JSON is fun. There are probably a few of you out there that are getting really excited, probably a really small percentage of you. But the real way that we expect tenants to interact with this is through the Azure Stack. So if you look at what we have in the Azure Stack, this is how tenants will create it. And those same JSON objects that I showed you through what we're passing into the controller is available in the Azure Stack, and you'll see it in the UI of the Azure Stack. So wait for it to refresh in. Probably should have pressed refresh before clicking on it. So you can see in this resource group, let me refresh one more time. Go back to the beginning. So all of the network objects get put into what's called a resource group, and then I can click on that resource group and then drill in piece by piece. I can go into the virtual network. I can see the virtual subnets all the way down and see all the objects that I've created. Well, I'm not going to wait for this to time out in the essence of time or to refresh. We've done lots of demos of this week. I'm sure you can find another session that has this, hopefully. All right. So before I move on and talk about some of what's happening in the host, I'd like to have Bala come up here and talk about some more of the core services that we are working on for the next version of Server.
Hello.
Log in there again.
Okay, just wanted to switch tracks a little bit and talk about IP address management. DDI, DHCP, DNS, and IPAM, you have a comprehensive set of capabilities that come bundled with Windows Server. And in 2012 R2, what we had done was to have IP address management to take care of both your physical and virtual network addresses. So you have a fairly substantial set of capabilities that you can apply in a data center setting to manage your both physical and virtual network addresses. So I just want to talk about what's coming new in the new release of the server that you can preview in the next preview. The three things that I want to talk about. One is the capability to handle multiple AD forests. That's if you're familiar with IPAM, I'm just going to be quick here. We used to just handle only one AD forest before. Now IPAM is able to handle multiple AD forests, and that it automatically figures by attaching to one AD and finding out all the AD forests. And that's shown here. Here, both Contoso.com and Fabricom.com, which are two different AD forests, will be handled by IPAM going forward. The second set of capabilities I want to talk about is the comprehensive DNS management that IPAM now brings. From a single console, you can manage all your DNS and DHCP servers. And in this release, the new release, we're adding DNS management capabilities, which are not there before. So you can see here in the DNS zone management and resource record management are the two capabilities we're adding. And here you can see DNS zones from multiple AD forests that you had shown before, Fabricam and Contoso. And if you look at the zones themselves, the kind of things you can do are adding resource records and then configuring preferred DNS servers, zone status, and so forth. And let's choose an individual zone and look at the resource records. The kind of things you can do are editing and creating DNS resource records, changing their properties, and so forth. So you can use a single console now here and handle pretty much all the DNS management capabilities that you would do in a typical setting. And finally, the RBAC capabilities, the role-based access control capabilities, are also enhanced to take care of a number of, sorry, I'm just in the wrong place here, access control capabilities. So when you add a new user role, we already have very fine-grained access control that you can give to individual administrators. Now IPAM introduces a whole bunch of DNS-based operations that you can assign at a very fine granular level to an administrator. The kind of things that you can do are listed here for zone operations, and then as well as for resource record operations that are here. So you can see, there's a lot of control that you can give to individual administrators to handle DNS operations in IPAM. Enough? Very good question. As of now, it's still Microsoft DNS and DHCP servers. But by the end of threshold, the new release of Windows Server, you would have the ability to deal with third-party DNS and DHCP servers also. Yeah.
Hold the questions just please, and let's finish
Sure.
finish the talk. We have very little time left.
Okay. I can meet with you also offline. Finally, the one thing I want to show is, now when you look at an IP address in the inventory and look at the DNS information, you can get comprehensive information about where this IP address matters, both the DNS records, A records, as well as the PTR records and all the other records that you have created where this IP address appears. So, I'd like to stop here in the interest of time and let Greg continue.
That's still thinking. Okay. So let's go back to now. So I'm going to show you, the last things I'm going to show you are some of the work we're doing at the Hyper-V host level around the network and some optimizations and things we're doing there. First thing I'm going to show you is RDMA. So today, many of you are using RDMA to get really high performance storage traffic through the Hyper-V host. But to do that, you have to have a separate set of adapters for that RDMA traffic that are separate from your VM traffic. Because when you have, you cannot enable RDMA on the virtual adapter for the parent partition. So all of your traffic without RDMA goes through the regular TCP stack, making heavy use of the CPU, and you don't get RDMA on that virtual adapter. So having separate physical adapters for RDMA then requires you to have more adapters, more cabling, and more physical switches. And the next version of server will now make it so that you can actually enable RDMA on the virtual adapter. This is the thing that's new. You can see this virtual Ethernet is now enabled for true. And you can see the same file copy that I did before is now going over RDMA. The performance counters became active, and you can see we're actually getting really good throughput on this NIC. CPU usage is also lower, even though it fluctuates quite a bit. So you can see here real quick that we have RDMA going through the vSwitch into the parent partition, and it can coexist on that same vSwitch with the VM traffic. Last thing I'm going to show you is Packet Direct. So Packet Direct, as Rajiv mentioned, is a technology that basically moves a lot of the processing of the network packets from the parent partition into the vSwitch, where it can more efficiently handle the interrupts and send the traffic to the VMs where it belongs. Here I'm going to show you a VM that is configured to not use Packet Direct. Let me kick off a sender. What I'm going to do is I'm basically going to flood this machine with millions of very small UDP packets. So this is a sender on a different host, and it's going to send to this VM. And you'll see traffic will pick up to around 1.5 million packets per second. So that's what this number down here is. You can see the green line right here is the current throughput. So that's very nice. Now let's enable Packet Direct. So I'm going to stop the sender, because it's really slamming the machine right now. And I'm going to run a script that will enable Packet Direct on this machine. So we've now enabled Packet Direct. You can see here it is enabled to true. I'm going to reset the virtual adapter, and now I'm going to start sending traffic again. And what you'll see is that with Packet Direct, we're getting about double the throughput with the number of packets per second that this vSwitch can process. This is going all the way through the host into the vSwitch into the VM. We've doubled the number of packets per second. I don't know of any other virtual switch on the market that can do this level of performance. We're getting 3 to 4 million here. All right. With that, I will hand it back to Rajiv, who will close things out.
So I'm going to summarize very quickly, and then we can take some Q&A. As Yusuf said, we have a slew of capabilities in Azure. Azure deploys at very large scale worldwide and brings these and does that using software in all infrastructural domains, certainly in the area of networking, and then brings capabilities to you so you can deploy your workloads at your discretion, whether on-premise or in Azure. We've taken those same sets of capabilities, the same technologies that exist in Azure, and we are commercializing them, and we bring them to market. And this entire talk was about showing you what you can do today in terms of really having hybrid deployments that scale across multiple data centers and go all the way to Azure, that free you from the rigidity of the day through your inflexible networking deployments, because now you've embraced time. Seen that in action, and then we've looked at the set of capabilities that are upcoming that will be available to you in the near future that are listed over here, segmented across various areas, whether it's foundational set of capabilities, our investments in the core, investments in additional services, including the same load balancing capabilities available to you in Azure, service chaining, service composition, and then going all the way to network control through REST and through PowerShell, so programmatic control as part of the Microsoft Azure stack. Hopefully this was a good use of your time. Thank you for making the time and being here today, and ready to take any questions.